Alright, so today we will start the lab. So, so here is a breadboard. So before we start the lab, we want to understand that how the breadboard works. So this is a very basic breadboard. Now, if you look at your own breadboards, I'm assuming that we have the breadboard right now. So there are different sections in the breadboard. For an example, let's say you will find that there is a top section and there is a bottom section, and in the top and bottom section, all these points, I'm saying along the row, you see the row, right? We just circle the row. Those are short. Now what do you mean by short? Those are basically the same point. So for an example, let's say if you connect a wire here in this point, okay, and then again connect another point wire here, you are basically making those wires short, basically meaning connected. Okay, so we use the breadboard to place all the ICs and connecting the pins. Now remember the last class we first talked about the logic gates, right? And at some point we show you that all the logic gates are basically some ICs. So we have to use some ICs to get the logic gates, right? So in digital circuit we will be building different circuits, the ones that you have seen in the quizzes. Remember the little bit combination of different gates. So to make those circuits, okay, you have to use those ICs where you have those gates, right? Let's say you are trying to connect an inverter to an AND gate. How do you do that? So you know that there is an IC for the inverter, right? And you have another IC for AND gates. In one IC you have multiple gates, but you can choose any of the gates. Let's say you choose one inverter from the IC of inverters, and you choose one gate from the IC of one AND gate from the IC of AND gates, and then you probably are trying to connect them. Okay. Now connecting means what? You have to run the wire between the pins of two ICs. So to run the wire, what you are trying to do? You are trying to connect those two pins, right? So to connect it, you have to run the wire here, and I'll show you another image that how it looks like. But before that, let me tell you this. In the top and bottom part, the rows are connected. Okay, that means all these are the same point. In the bottom, all these are the same point. In the middle two sections, the columns are short. That means all these points here is basically one single point. So if you run a wire from here, let's say, and if you run another wire from here, they are basically, technically they are connected to each other. You see what I'm saying? And similarly in this section, all these columns are short. So in these two sections, this section, this whole section, and this whole section, the columns are short. In the top section and bottom section, the rows are short. Okay. Now let me show you another image to understand it a little bit better. Now let's say so once we build a circuit in a breadboard, it may look like this. It's an example of how it should look like. For an example here, what did we place here? We have placed two ICs here. I think we all know the ICs, right? We have seen the ICs. And as you remember that all the ICs has some numbers, right? In general, in this class, most of the ICs we'll be using will be starting with 7-4. So they are basically the series of 7-4 families. It doesn't mean that all the ICs will be 7-4 forever, but just for most of the logic gates that we'll be using in this class, we'll be starting with 7-4. So the 7-4 doesn't make any difference to us because most of the ICs will be starting for 7-4. So the most important digits will be the last two digits. Let's say for all the inverters, the IC is 7404. over the time we'll memorize it and we'll know it because we have it in instruction written, and for every IC we have a data sheet, okay? And in data sheet you will see the layout. Remember we have the layouts in one single slide of chapter 3 where we have showed you all the ICs together, and because we need to understand that, just to understand which is the input pin, which is the output pin, right? Because let's say even you are using inverter, you need to know which pin is input, because one pin is the input of the logic gate, right? Another pin is the input of the output of the logic gate. So we'll get back to that point again. But here, let me show you something here. Let's say we place two ICs here, okay? Now, let me make it a little bit enlarged. Maybe I can show you something better. All right, let's see. Now here, now if you look at carefully, do you see a small notch here? Do you see the notch? And here as well. So every IC has a notch like this, okay? So when you place it, you should always place it in the middle. Do you see we have placed it in the middle? The reason we placed it in the middle because there is another strip here. There's a blank spot here. Do you see the blank bar here? No, with no holes. We place the ICs here because we want to make sure that one side of the pins are not connected to the other side of the pins, because we know that everything here are short along the column, right? But these columns are not short with these columns. So we place the ICs along this strip, okay? And we keep this notch at our left. You always keep the notch at the left. You saw that, see, this is left, right? Everything is left. The reason we do that, because once you place the IC, you need to know the pin numbers, right? Now you always start counting from here. So this is your pin 1. This is your pin 2. Do you see it? Do you see my mouse? Okay, it's pin 1, 2, 3. So all the way to pin 1 from what? Pin 7. After 7, this is going to be 8, 9, 10, 11, 12, 13, 14. Now you have 14 pins here. It doesn't mean all the ICs will have 14 pins. Some ICs will be like 18 pins, 24 pins. There are different ICs, different number of pins, but almost all of the ICs will have a notch, and your notch should be at your left, because otherwise you will be counting the pins in wrong order, and the IC will not be working. You might burn it out or something. So make sure when we place, it doesn't matter where you place. You can place it here, you can place it here, you can place it almost. I'm saying instead of placing it here, if I place it here, it's still fine. It depends on, I'm saying you might need a little bit of space so you can move it back and forth, but it doesn't matter whether you place it here or here or here. Along this line, as long as it is on this line, it's fine. Okay. Now, let me show you one single thing here. Let's say here, look at this. This is called a dip switch. I'm not sure, have you seen the dip switch before or not? But this is a dip switch. We'll be using this kind of switches a lot. Okay. Now, the purpose of dip switch is because you can basically flip the switch. Okay, there are 8 switches here. Okay. Now, using these 8 switches, you give 1 and 0 to the circuit, because at the end of the day, in the digital circuit, you will be your input will be either 1 or 0, right? And output will be 1 or 0. So to give the input 1 and 0, we use this kind of switches. These are called dip switches. So you have like 8 switches there. You probably will not be using all the 8 switches together in one lab. Maybe in some lab you might need more than 8, but the beginning ones, you will not need all the 8 switches, but you can choose whichever you like. Okay. So whatever switch you want, you can just use those. Okay. Now let me show you something here. Now let's say this is your first IC. Okay, and this is the number of the IC 7400, which is basically a NAND gate. You'll know it because we'll know it soon. And this is an inverter 7404. Okay. Now here Do you see that we are running the wire? So look at this. We are running the wire like this. We started from switch 1. Do you see the white wire here? Is it visible? The white wire here. There are two white wires, right? Can you see it? Okay. Now we are running the white wire starting from here to here, and then we started the yellow ones from here to here, right? Now tell me, do you see that white wire is connected to the yellow one? Why? Because this white one is connected to the yellow one. The reason is because they are connected on the same column. As long as they are connected on the same column, they are basically is the same. And maybe I can probably show you a different example. Maybe that will be better. It's a little bit colorful. Is it better now? Because the other one was like little bit, all the colors were like white, yellow, so it's not too visible. Now you can see it better here. Now let me show you something. Just ask you something. This is not exactly the circuit we'll be implementing, but this is I'm using as an example, just to show you that how you can connect the wire and understand how they are connected, or you can connect those. Now let me show you this. Do you see this red wire here? Okay. Now, and another red wire here. What do you think? They are connected?
Yeah.
Are they connected? Meaning short? Short means connected, right? Because you see they are in the same column, right? You see what I'm saying? Do you see this is connected to this column, and this is also connected to this column. That means they are basically this red one and this red one, they are exactly connected to each other. I'm just trying to give you an idea that how you will be running the wire if you want to connect. Now let's say this is the IC, right? And this is the pin 1, right? Okay, now let's connect. Let's start counting from here. Pin 1, 2, 3, 4, 5, 6, 7, which is 8. This one? Okay, 9, 10, 11, 12, 13, 14. Okay, now, can anyone here tell me, so this is your pin 12, right? This is 12, and this is what? 14. Now, can anyone tell me that whether these two pins, 12 and 14, are they connected? How? Look at this one. Look at this little wire here. Okay? What it is doing here? This is connecting this column, right, with this column. Now, this column is what? This is the column of pin 12, right? And this is the column of pin 14. So basically, you are connecting pin 12 and 14 by this wire. So I'm just trying to show you that how you basically, you can run the wire in the similar manner. So whenever you will have to connect, let's say, pin 5 of one IC to pin 7 of one IC, you probably can do it right now, right? So, and also, the top and bottom ones, I know that some of you have, you probably have bought the breadboards from different manufacturers. So some of you may not have two rails here. These are called rails, okay? You probably have only one here and one here. That's enough, okay? Now the top and bottom ones, the top one, because this is connected along the row. You see what I'm saying? This is connected along the row. The top one we use as VCC. Now what is VCC? 5 volt. Remember I said in digital circuit most of the voltages are either 5 or 0. So we use the top row or whatever the row. It doesn't matter. It has to be top row. It doesn't matter. But mostly it's top row. We use the top row for the voltage 5. Now how do I get voltage 5? When you go to the lab, you will see there are stations. We have voltage 5 there, so we run the wire from that station, and then we connect to any of the holes here. Now let's say this is the top row here. You see here, I showed you that 5 volts DC is, let's say, connected to this hole. Okay, I'm just assuming. Okay, now what does it mean? This means all these things like these two registers, this black wire, this register and everything you have in the top row are basically getting the voltage 5. You see what I'm saying? Because I said the top row is connected, right? All the holes are basically the same point. Now, if you are connecting the voltage 5 here, that means everything is getting voltage 5, whatever is connected in the top row. That's how we use the top row, because we just connect the voltage 5 from the station, and then we use every single hole, or whatever the hole you want. It doesn't matter, because you can keep some holes blank, or you can extend whichever you find closer. You can use that hole. To run every IC, there should be a pin. There must be a pin which will need voltage 5. It will be defined. It should be there in the layout. I'll show you the layout again from the slide or the manual. We did that manual today as well. So, because it's something like you are trying to operate the IC, okay? It's something like, it's just a digital equipment, right? So you have to give some voltage there. So there will be a pin. Most of the ICs, the pin is 14. Not all. Don't trust on this. Just check the layout. It might be a different pin. Most of the ICs is pin 14. So the pin 14 mostly connected to, most of the cases is connected to voltage 5. In most of the cases. Not here, because it's a different IC. And there must be a pin which must be connected to the ground. We all know the ground, right? Which is voltage 0. So we do the same with the bottom rail. In general, one of the hole of the bottom rail we connect to the ground. You will get the ground there as well in the station. Okay. Now here in this image, I tried to show you the ground. Let's say I'm assuming this pin is connected to the ground. That means what? Everything connected to this row is basically connected to the ground. You know what I'm saying? All these things like this black wire and all these registers, this black one, everything is technically connected to the ground, since this hole is connected to the ground, because you know that row is short. You know what I'm saying? So we keep the bottom rail for the grounding and top rail for the voltage 5 in general. Okay. And again, as I even if this is not mentioned anywhere, remember this: every single IC you will have a pin which needs to be grounded. There will be another pin which needs to be connected to VCC or voltage 5. Okay. Now, I might be able to show you that here, I guess. Okay, I have to download that maybe. Okay. Now, so if you have only one single rail at the bottom, so you are still fine. Okay. You may not have two. In some cases, some breadboards just have one here. So it's only one. So mostly you use the top one. So if you have two here, what you can do is you can use either one. You can use the top one probably as a VCC and choose anyone from here. But remember, if you are connecting to this hole, that means the top row is connected, not the second one, because second one is again separated. It's a single row which is. See this. That doesn't matter. See, in general, breadboard, they try to draw some lines, and they try to show you a red line and yellow and then blue lines, but that doesn't make any difference. Whichever row you want.
What I'm saying though is
you can choose any row there.
the 5 in the top and the 5 at the bottom hot at the same time.
So,
are these two lines interconnected?
that doesn't matter. I'm
No,
saying,
I'm asking, are they?
yeah, no, there is no voltage there if you are not connecting anything to the station.
So if I connect here, I'm not automatically connected.
No.
That's what I'm asking.
So technically, at this point, look at this. For an example, his question was, there are two rows here, right? And there are two rows at the top. So technically, there are 4 different rows. What does it mean? It means you can have 4 different set of voltages. Now, if you need only 2, just use one from here, use one from there. It doesn't matter technically. But sometimes they try to, do you see there are some lines drawn there? They try to draw a red line and blue line most of the cases. So they try to help you out a little bit, because they try to tell you, okay, use the red one for VCC, blue one for grounding. Now, it doesn't matter basically, because it's just an indication, or they They probably try to keep you organized. You know, when you have too many connections and too many voltages, you might want to use some of those, but it doesn't matter. Even if you use the blue lines, blue one for voltage 5, technically that doesn't matter. But I hope that we will be always using the red one just to, but that technically the circuit will be still working, because as long as this row is short. All right, so there are plenty of things coming, and before okay, now let me show you a little bit extra. So here, before we start any lab, okay, we will have the lab manual for sure, and there will be, for some labs there will be some discussion. For some lab, we will already know the material because we covered everything basically in quizzes. Everything, before you start, you will realize that you pretty much know what we are going to do based on the quizzes, because that's how we design the quizzes. But still, what you want to do is you want to go to lab help. There is a lab help tab, and all the labs are here. So if you click lab 3, you don't have the instruction here. The instruction is on the manual. I'll give you the manual, but you will see all the schematics and images here. Now what is schematic? Now let me show you a schematic here. Now this is the schematic of, let's say, lab 2A, the first lab. Okay, so it is basically telling you that which IC you are going to use and what will be the pin number connections. Now for an example here, let's say what we are trying to tell you. Let's say here, look at this. So this is pin 3 of 7400, right? And this is pin 1 of 7404. That means you will be running a wire from pin 3 to pin 1. Meaning pin 3 of 7400 to pin 1 of 7404. That's what I'm saying? And also, so these are some, this is the schematic. Over the time we'll be using the schematic, we'll understand it much better. And let me show you a little bit here. Do you see some LEDs here? I think we all know the LEDs, right? We use the LEDs, okay? We use the LEDs to see the outputs. As I said, we use the switches. We use the switch to give the input, right? Because you have to give the input to the circuit, right? 1 on 0. So let's say A is 1, B is 0, or C is 1. That's how we give the input, right? So let's say you are using 3 switches, and out of 8 you can choose any 3, whichever you like. Okay? Just assume this is your A, this is your B, and this is your C. That's how you connect it, and then at the output you have several ICs. Now let's say output is only X. So you will have one LED for that, because if the LED is turned on, that means you are getting 1 there. If the LED is turned off, you are getting 0. Okay, because that's how, because you need to know at the end whether you are getting 1 or 0 for some combination of input, because you will know exactly what you are expecting. Okay, how do you know it? Because for every single circuit we will have a truth table, and truth table will exactly tell you what you should expect when. Remember the truth table of the logic gates. Similarly, we can write the truth table for every single circuit. We'll learn it soon. I'm saying we have not done it yet, but I think we can guess that we have something like this. Now, also for the labs, we have, let's say here, if I go back to lab 3 again, we have images. So let's say lab 3, there are like 4 different parts in lab 3. Now if you click the image, you will see that we try to show you an image of the lab, so that this is like an help, okay? But everybody can use this image, there is no problem with that, but make sure you understand what you are doing, okay? See here, these are the ICs, and I tried to make it as close as possible when I took this picture, as clear as possible, but still after I tried hard, but still some of the ICs is not showing the number, because numbers are basically written here on the it was written here, but for some reason, because of lighting or something, it's not displaying. But I think we'll understand which IC is what, which one is 7404 or which one is 7400. Here? Yeah, okay, now this is a specific board. I found a lot of students in past semesters, they bought it from the Radio Shack. This is a specific one where this side and this side, they are not connected to each other. I'm saying, so technically there are 8 rows. How? this is one row, okay, and this is row number 2 at the top, and this is another row. Now this is another row. There are 4 rows at the top, and there are 4 rows at the bottom. So that's why if you are trying to, let's say, use the whole row, we have to make it short here. It doesn't have to be short in every other, I'm saying, maybe in other breadboard. You know what I'm saying? But we made it short. Do you see this green, small green wire here? And same is here. We did it because both sides was not short. Some of the IC, some of the breadboards are like this because they try to give you more rows so that you have more choices of voltages. Because the more rows you will have more variations of voltages. That's not probably useful for this class because we just need 2 voltages. But in some other classes, because the breadboard is not only for the digital circuit, you can do some electric circuit. There are some other things there. Okay, so in those cases, they might need like 5 different voltages or 6 different voltages, right? Voltage 12, voltage 5, negative voltage 12. So there are plenty of different other voltages they might need. So in those cases, this kind of breadboards are very useful because they have like 8 different combinations of rows in the top and bottom. So, but we keep it short just to make it the whole row just like this. But in general, the the green, this green wires is not probably required. Okay, but again, just even if you don't require it, if you keep it there, it will not mess anything. Okay, but this is this is a very close look. Okay, so for every single circuit or schematic we will be building, we have such a schematic here. Okay, so what you can do is you will have all those ICs, will give you ICs you will need for the lab, and also you'll have the manual. You'll have the schematic here and in the manual and instructions. So what you can do is you can just look at these ICs from here in the classroom, because I'm not sure whether we have, because some of the computers there is out of the network of the Southwest. So you may not be able to access POS. So what you can do is you can stay here, okay, look at these schematics, look at these images and build the circuit, and then go to the lab and demonstrate it. You see what I'm saying? Because in the lab, all you need to do is just connect to the power and demonstrate that. Okay? And there is another way even to connect it, because there is a way you can, instead of connecting the, instead of going to the lab and getting the voltages from there, you can also use a battery. Okay? I'll show you how to do that. I probably will upload an image so that you will see how you can use the battery instead of, because if you have that option, I'm saying, that's just a 9-volt battery, just one battery, and there is a connector there. If you use those, the good thing is you don't have to wait until you go to the lab. You can work at home, because it's just what, the breadboard and set of ICs, because we'll give you all the ICs today, or let's say the package. So that's your package, so you can keep it with yourself, okay? And then build your circuit wherever you are. Even if you're not in the lab, you can still build it. If you have the battery, that part, then you can still run your circuit anywhere, just to make sure you, and you will know exactly what you are expecting. I'm saying you will know the truth table, and you will know exactly whether the circuit is working or not, and then you will demonstrate me and I'll sign you off. Okay? Any questions so far? I'm sure that there will be questions, because we are just starting, and that's not uncommon that we'll have questions. Okay? Yeah.
Where you say that you jump to get power to the other side, is this where you determine where you put a jumper right here, or how do you determine it?
Yeah, this is how. Look, do you see? So for this specific one, you see this is like circled here, and this is like circled. That means this side is not connected to this.
Okay.
Yeah, because there is a middle part.
Okay.
For this specific one, it's not true probably for the other ones. Okay. Not for his one. Okay. Now look at this. Look at this one. I think most of you have something like this. Let me give you some indication that how do you understand that this side and this side is not connected at the top and bottom. Because I have seen some breadboards, the red lines are not continuous. In the middle, there is no red line. There was red line here, there was red line here. Guess what? This side is short and this side is short. If you want to use the whole row, you have to just, you have to keep it short, just like the yellow one. Yeah. Similarly here, I'm not sure how they indicate it, but there is a small W here. I don't know what is the indication of the W. So it's, for some reason it's not that probably an indication. And the indication here is probably the left side. You see this, everything is in a hole. If you look at carefully, you will see it. Do you see there is a block here? They have tried to draw a block here and block here separately. Okay. In the middle there is no block. I'm saying, so that means these two sides has the same issue. But I'm saying that's not a problem, but that's not probably required for this class, but that's still fine. But, and also as I said, for each and every lab, we'll be, again, we are building the circuit just to see the circuit, whether the circuit is working. That means what? That means for some combination of input, we want to see what is the output, right? And to see the output, we'll be using the LEDs, right? Look at the circuit. In every circuit, you will see that LEDs are connected. And mostly what we do is, let's say, can you tell me which this LED is connected to which pin? This one. So, look at this. In one side, this is connected to the ground, right? This is the ground. In other side, this is connected to which pin? Pin 1. How? Look at this. This is connected to here. Look at this. This is connected to here. And through the register, this is connected to pin 1. Do you see it? So basically, you are trying to see the output at pin 1, right? Because you are basically connecting the LED to pin 1. And remember, the other side must go to the ground. Most cases. Okay? Now, in LED, when you will be working on the LED, you see there are, the LED has two legs, right? Two legs. One leg is a little bit shorter than other one. You see what I'm saying? That shorter leg, remember this, because otherwise you will burn out the LEDs. The shorter leg always go to the ground. There are two legs, right? One leg is a little bit shorter than other one. If you look at very carefully, you'll see like this. Yeah, LEDs, yeah. The shorter leg will go to the ground. Remember that. Otherwise, you will not be working and you will burn out that, okay? And look at carefully. Every time, it's not mentioned in the schematic. It's not mentioned in the schematic, but look at this, pin 7. Do you see it is grounded here? It's not mentioned even in the circuit, because in most of the cases, we assume that we don't mention that in the schematic, okay? Look at this, pin 14. This is the pin 14, right? That's connected to VCC. Look at the pin 14 here again. This is connected to VCC. Now you don't have to, even if you connect here, it is the same thing, but it's connected to VCC. Do you see again pin 7 is connected to ground? Because that's how the IC works. Now let me show you a little bit here. Remember the last lecture, which was on chapter 3. Let's see.
So if it's not in the schematic, it still has to ground.
How do I know it? Which one to be grounded, right? In general, I said there's 7 and 14, but you will be also able to know it from here. Let me show you here. Now, I think we all remember this slide, right? We were talking about this one. Do you see every IC, doesn't matter which one, do you see there is a GND here? That means that pin has to be grounded. Do you see one pin is written VCC? In general, that's 0 and 14 for this class, but don't rely on this. Because in the lab manual, I'll give you the lab manual today, you will see at the end, there are data sheet for each and every IC you will be using. So before you use the IC, you should check the data sheet just to make sure that whether because you also need to know this. Because you also need to know which pins are the input and output, and they're quite different. For an example, let's say this is a 3-input OR gate, which is 7427. For an example, okay? Now look at this. Now 3-input OR gate means what? There will be 3 inputs and 1 output, right? Output is always 1. Now if you notice carefully, the inputs are this, because there are 3 gates, right? Now let's say you need 1 gate. Which gate you are going to use? Because there are 3 gates, right? Do you see it? Let's say 7427. There are 3 gates here, right? Which one you are going to use? Any one. It doesn't matter which you are going to use. Don't assume that you have to use the first one or second one. You can use any of those if you need 1. Okay? If you need 3, then you'll be using all of those. Okay? Now, let me show you something here. Now, the inputs for the first gate is 1, 2, and 13. Do you see how weird they are? And the output is, look at this, output is 12. So they're quite different. So you need to know exactly which pins are input and output. They're quite different between ICs. Now, look at this one. Let's say this is 7402. This is a NOR gate. You probably don't see the bubbles here, but you'll see the bubble in there is a bubble. I think it's not visible well. So the inputs are what? It's 2 input NOR gate. So let's say for the first gate, this one, inputs are 2 and 3, while the output is 1. So you always want to check the layout, okay? Make sure your schematic has most of the information, but sometimes in some of the schematics, we intentionally did not mention the pin numbers. The idea was just to make sure you can find it out. We can tell you everything, but that will not help you out. So that you know you are using one gate, we did not mention which gate to use. You can choose any of those out of 5 or 6 or 2 or 3. Okay? So you decide which one you use, write down the pin numbers there in the schematic. You can take a printout, write down the pin numbers, and then you start running the wire. Okay? Pretty much, or you can look at the image also, and in the image we are using some gates out of like 4 mostly we are using the first one, most of the cases. Okay? If you need only one. Okay? Now, before we start the lab, I'll give you the lab manual today and also a package containing almost all the ICs, LEDs, registers, and also most of the things that you will need, you will get there unless you miss something. One dip switch. So we'll give you all of those. So you will keep your package for the whole semester so that you can build your circuit, everything for every single lab. But before we start the lab, before we start lab 3 today, there are 4 parts in the lab 3, but before we start that, we will first do the quiz. There is a quiz in the quiz section. The name of the quiz is pre-lab 3. The reason we are doing the quiz, there is no literature type of question. All the questions are like, you will be given an image, and you will be asked a question like, is the pin 2 and 4 connected? You have to find it out, because that's just a breadboard and there are connections there. Just to make sure you understand and realize how things can be connected, okay? So let's do the quiz. Remember, you cannot start the pre-lab 3 if you are not done with all the 5 quizzes of chapter 3, okay? Because, you know, it's just something like a training, and what happens is, even if you try hard to understand chapter 4 right now, you'll not be able to understand it because you don't understand chapter 3. Do you see what I'm saying? That's why we keep that sequence, just to make sure you start the quiz in the right time. Remember this for the whole life. It's really important to keep the sequence. That's why in Southwest, University of Memphis, doesn't matter where you go, you will always see some kind of prereq requirement, right? Why do you do that? Do you think if you don't do the prereq requirement, it will be better for you? It will not be better for you, because you will take the class, you will not understand anything. You know what I'm saying? That's why it's important to understand the sequence and importance of the sequence. So finish if you have any previous ones, because I know that most of you are done with chapter 3. If you have not, I can see it here, but just in case, if you are not done, finish all those and then start pre-lab 3, and then we'll start the lab. And you can build your circuit here, just sitting in this class, because you have images, you have breadboards, and I'll give you the ICs, you'll have schematics and everything, so you don't have to run into lab right now. That's what I'm saying? So let's stop our discussion right now. Let's go to the quiz section and finish the quizzes, and meanwhile I'll give you the manual and the ICs and new package. Any question today? All right. So let's start the quizzes and let's finish it, and meanwhile